Hello and welcome to my video on basics of graphs. So there are a bunch of different types of graphs that you can use. I'm just going to go through some of the basic ones, some of the most simple ones, and then from there some of the concepts are really the same thing going from graph to graph. So I hope this will help you. So this one is kind of one of the weirder ones. This is called a histogram. It seems like a weirder one. It's more confusing to use right away, but then after a while, it's like, oh yeah, that makes a whole lot of sense, and it's actually very simple. So a histogram actually just has a whole bunch of random points. It just has some random numbers, like here we have 65, 75, 77, 45, just a whole bunch of random numbers. Um, I just randomly typed them in. They're random numbers that might look like what you might have on a test. And by the looks of it, a test that went actually fairly well for a class because the average is higher than the 65 right here, which is where you'd normally see a peak on most tests. It's actually to the right of that, which means it's a good average, which we can see all that because of graphs, and it's awesome. From just looking at these numbers, we can't see how good the test went because we see a 45 and we're like, oh boy, someone didn't do well. But maybe one person had a bad day. Or we see 100 and we're like, oh, easy test. But maybe that person had a really good day. So we can't look at those outliers. What we look at is the whole thing. And graphs are beautiful because they let us do that. So random points. This is called a bell curve. It's a very important thing, and it's because we have a histogram. So with that in mind, here we have basically you can see it's a range of percentages and then the number of people that were in the percentage group. So here we have 40 to 50%. Well, only one person got that, it says. And if you check through here, oh look, only one person got below 50%. So it got 45%. And then you can look between any range and see how many people were there. So if I want to know how many people got 100, well, 100 and above, only one person. Here, between 90 and 100, two people. So you can see any group. So that's what a histogram is. Basically, a bar chart, just like I have written here, basically a bar chart or a bar graph with ranges, but instead of you having to like literally go through and count them and go, okay, how many 70s are there? There's 1, 2, 3, 4, okay, 4 70s, and then you put it in. Hold on, 70 to 80. So what? See, and that's the problem. So 1, 2, 3, 4, 5. See, and I miscounted. So that's the whole thing. So you want to make sure that you count properly, and if you do it this way, then it's actually more likely to make a mistake, and this is a better way of doing it. So this is a very, very important statistical graph that we can use. But there are a lot of other graphs to use, so let's just scroll down and look at the next one. So here we have a graph comparing the favorite types of apples for different people. So we've got red apples, green apples, yellow apples, and the number of people that liked each. So we've got 17, 16, 2, so it's out of a class of 25 kids. And so you can see, well, quickly here we can see that red was the most favorite type of apple because more people chose it. So whenever you're looking at a graph, there are two things you want to look at right away. What are the axes? So what is on the side here and what is on the side here? Well, this is the number of people that chose, and this is favorite type of apple. So you want to be choosing, you want to be looking at those axes in order to understand what the graph is. Okay, let's go down, and this is the same data, exactly the same data, but it shows it differently. So depending on how you want to look at it, this one here shows you, even converts it to percent for you. So I guess I should have color coordinated that too, which I think you can do. Anyways, but our red is blue. So our red apples have the 68% of people chose it, green apples have 24%, and yellow has 8% of people. So You can see here that there are that this might be a beneficial thing, especially when you're talking about percentages of people, because then you can always compare it out of the whole. Whereas this is just a random set of people. You don't know how many people there are. I mean, you could count it, but you can't even necessarily know for sure if that's 2 or 3, and if that's like 16 or 17. So this might be a nicer graph in some situations. And this is, for me, the most interesting type of graph because it's used so often in math and in science for so many different things. This is the type of graph that we use to get averages in order to understand situations and physical realities quite often. So time versus something else graph, and that's probably the most common type of graph as well. So this is a distance ran by a soccer player during a game. I looked it up, and roughly a soccer player in meters does about 15,000 meters, or 9.5 miles per game, and games are 90 minutes, so it's roughly a correct graph. Maybe this is a little bit lower level than whatever information that I looked up, but basically there are a whole bunch of points, and I'm actually going to first take this off. So most graphs will actually just have these points, just a whole bunch of dots everywhere, and then what you do is, if you have it on a piece of paper, you take a ruler and just eyeball and just draw a line. On the computer you can add a trend line like this, and it will just add a straight line through the majority of the points. And so some points are below, like this one, some points are above, like this one's above, but it's just like roughly evening it out. So that way you have an average of what this soccer player ran for any given point in time. And realistically, I made up these numbers really quickly, but realistically it'd probably bounce a little bit more. But you might see this straight line. So again, to understand the graph, you look at the axes, you see minutes. Well, at 20 minutes, they ran about 4,000. Is that right? Close. At 40 minutes, they ran about 6.5. Okay, yeah, close. So you can see that you can use these lines and these lines in order to understand what happened at any point in the graph. So whenever you're looking at a graph, look at the axes, and then you can understand what's happening. I hope this video helps you understand graphing a little bit better. Good luck.